Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the old standard hi-fi record player, and I think we're going to tackle the power supply section we have here. Now I've removed it out of the case already just to save a little bit of time on this video, because I'm sure you didn't want to watch me unscrew three screws and swear for half an hour while I tried to get this out of the damn case. But anyway, like I said, I have got the power supply out of the case, and we've got it ready to work on. And basically what we're going to do today is we're going to see if we can get this thing into working order and see if we can get it to produce a nice 9 volts DC output to power the rest of the amplifier in the record player. And what we're probably going to do is we're going to find a better solution for this horrible abomination which has been bodged in there. We will obviously test the mains transformer and make sure it's actually still good. We will replace this broken fuse holder and wire it in a little better way as we're going to replace this. I'm going to replace that figure of 8 cable with an IEC like that, so we can actually provide an earth to the record player. It also means that we can wire this with the fuse right in the live terminal and make sure it's connected permanently into the live terminal, where with the figure of 8 the fuse could either be in live or neutral depending on which way round you connected the connector. So all in all, we're going to make it into a much safer record player to use by doing this. And also, I've been chatting with another restorer and repairer, and that's Andy over on Vintage Electronics Repair. Now if you haven't seen his channel, I will include a link in my description for his channel. He does pretty much the same kind of radio record player type repair work as me. He doesn't really do that much on computer side, although I did see an Atari 2600 sneak into one of his videos. He's more on this type of stuff, and me and him have been chatting since I started this restoration, and we've both come to the conclusion that this player was most likely actually made in Japan. Now I hear you say, but you've already said that it's full of British components, and I know that, but as Andy actually pointed out, looking at the style of the record player, it is very, very much Japanese. There was a lot of electronics produced from the late 60s when they really started producing consumer electronics for export, and they do have a certain look and style about them, and this does fit in with that style. The other thing that makes me believe this isn't a British record player is if we look on the back here, we've got 2 voltages. We've got 110 and 220 volts AC. Now really, these weren't used in Britain. We used, alright, fair enough, prior to that we used all sorts of different voltages in the UK, both AC and DC. But by the late 60s it had pretty much been standardised for most of the country that we use 240 volts AC for our power. Well, this is 220 volts. So I don't believe this unit was really ever intended to be sold in the UK. It's actually probably more likely that with it having a 110 volt tap in 220 volt, it was actually intended for Europe. Because up until relatively recently, 110 and 220 volts were the standards in Europe. I remember back, I'm showing my age now, but this was in the very early 1990s, going to rural France on a French exchange visit with school. And the family that I was staying with in a small village, all their stuff was still on 110 volts. And the rest of France was on 220 volts. Both voltages were pretty much used universally in France up until probably the very, very late 1990s. If anyone's over there, you can correct me on that, please do. But I distinctly remember when I went over there, like I said, in the very, very, very early 90s, it might have even been like 1990, that village was still on 110 volts. So there's a very good chance that this record player was probably made for export, and it was probably made for export to Europe, and then it's somehow arrived over here in the UK. So what we are going to do, to be honest, the extra 20 volts through that transformer really won't cause a major issue, because we're not pulling a huge amount of current through it. We're not even pulling as much current through this record player as it would have originally, being that we're replacing the DC motor with an AC induction motor, which obviously doesn't use the transformer at all. So I've not got a major problem with that. All we're going to have to do is check that we've got about 9, I'll be happy with it, say goes up to about 10 volts, but we need 9 or 10 volts out of this thing to actually run the amplifier in the record player. Now, like I said, that isn't going to be a major issue, the fact we're just putting a few extra volts through the transformer. Now, that's another thing. They'll say, but you're only putting an extra 10 volts through, because we're now 230 volts in the UK, not 240 volts. And that's not actually really correct. What they did, when we homogenized with Europe, and Europe was 220 volts and we were 240 volts, and we homogenized all on 230 volts, it's a load of rubbish. All that they did was change the tolerances of the standard, which used to be 10% to 20%. So we're still 240 volts. If you measure your voltage in the UK, it will be around about 240 volts. If you measure your voltage in France, you'll probably find it's close to 220 volts than it is to 230 volts. So they mess about with things like that to standardise us with Europe. But anyway, that's a completely different subject. What we will do is we'll get cracked on with this this little power supply. First thing I'm going to do is I'm going to remove this abomination here, and we'll see how much damage has been done to the rest of the unit. Let's get these. Find a better screwdriver to do that with. We'll get these. I thought this might be a machine screw, but it's the most ridiculously long self-tapping screw I've seen. It's not. It doesn't even fit properly. I mean, look, watch. I mean, that's safe, isn't it? Honestly, some people really shouldn't be allowed to touch electronics. And then we've got a wood screw on this side. So let's get these out. And we can take this bodged in figure of 8 connector out, and we'll see what we can do to make something better than that. Right. So let's get that wood screw out of the aluminium there as well. Like that, and they can be got rid of. Well, they can go in my spare screws box. And here we have the figure of 8. As you can see, we've got half of the fuse holder on that side, and the other side goes straight to the transformer. Excuse me. So we'll unsolder that for now. Let's just get the old iron. Hopefully this is heated up. Let's get that off there. And the first thing we're going, if that will melt, there we go. The first thing we're going to do is I want to test that transformer and make sure that it's actually going to work. So we will rig that up using my safe block and some crock leads, and we'll connect mains up to it. In fact, should we be really safe and can use it, run it up through the variac? Yeah, let's be really safe, and we'll run it up through the variac, and then it looks like I know what I'm doing. Right, so where's my safe block? Where's my safe block gone? Oh, there it is. Right, so we've got the old safe block here, and I'm going to connect that. I'll put that on there. I'm going to connect that to my variac. That means that I can start at a low voltage, and I can crank the voltage up to 240 volt and monitor what I get as an output from them to the AC output from the transformer there. And we can see what that is with 240 volts on the transformer. But we can do it in a reasonably safe way. We'll move all the rest of the wiring out of the way so we can actually see what we're doing here. So let's open the safe block up, and we'll use some crock leads on the safe block. So if we connect that to that side like that, we'll connect that to that side like that. Now I will say now that the variac isn't plugged in at the moment, so we are being safe. We are working with it disconnected just while we connect all this up, and obviously the safe block is open there. If you can just see, the safe block is open, so I have no chance of getting a shock while I fiddle about with this. What we will do is we'll take the red wire, that is our live, and we will connect it to the blue coming out of the transformer there. And we'll take the black wire and we'll connect it to the half of the fuse holder, which is still, I'll have that in a safe place, which is still connected to the chassis down there. So that is basically going to energise the primary on the mains transformer, and then we will measure the AC voltage on the secondary there and see if we get anything. It's just much safer than just plugging it in and showing it the mains, this, because we can see if it's doing anything. It's a much lower voltage, and like I said, and then we can crank the voltage up so we can actually see what's going on. Now it's not in shot. I'll put that there so it's in shot so you can see what it's actually doing, and we'll set that onto the 200 volts AC range. We shall plug in the variac. That's the variac plugged in. We'll switch the variac on. That's my variac on. Now we'll set it to, let's start at 50 volts, which is a nice safe voltage to start at. We've got our meter set there. We will close the safe block. So that has energised the transformer. Like I said, only at a low voltage. We've only got 50 volts AC going into the transformer for this initial test. And we'll just see if we've got any AC coming out on them two pins there, which is the AC output from the transformer. So if we go on that pin there and that pin there, and we have got 2 volts there. Like I said, we are right down at 50 volts, so we will increase, in fact we'll increase the auto transformer, the variac, sorry, to, let's go up to 150 volts. So we're still well below what this will normally run at. And again, we will just test between there and there and see what we've got. Okay, we've now up to just under 5 volts, so that's looking okay. Let's go up to 200 volts. So I'll increase the variac up to 200 volts, and we will test again. As you can see, we've got 6.6 volts there, and let's take it up to 240 volts. Because like I said, even though we're meant to be 230, I know for a fact that the mains voltage in this area is anywhere between usually 235 to 240 volts. So there we go, we're at 240 volts on the variac, and we'll see what output we've got from the secondary, AC secondary on the transformer. Oops, careful. And we've got 8.1 volts, which is absolutely lovely. So let's switch the variac back off, turn the meter off, disconnect the safe block. Basically what we have done is we've confirmed that that transformer there is actually good. It does actually work okay. So our next port of call is going to be basically replace what was in there with that, which is going to make a much neater mains input. Now what I will do is I will pop down to my other workshop to do this, because I've got some more machining tools down there, and I will be back on this video as soon as I have that installed in the actual case. So this will probably take me a while, but for you it will be instantaneous. So toodle pip for a second, and I will be back in a minute. Okay, we're back, and as you can see, now doesn't that look better? That didn't take me too long to do. I basically just used a drill to drill the rough hole like that, and then I just used a file like that and basically just smoothed the edges of the hole out so it's the right size, fitted it in and drilled 2 holes for 2 nice machine screws. It's a pity didn't have any black countersunk ones, but I don't think they look too terrible and they're nice and tight. I certainly think that looks a much neater installation than that bodged in there with some wood screws. So as I said, we've got a nice mains input now, so time to turn our attention to how we're going to wire that up inside. And the first thing we're going to do, now we've got a proper polarized input where we know that this side here is live, that side is neutral, and we've actually got a dedicated proper earth now, is we're going to remove what's left of that old fuse holder. Hang on, I accidentally caught that wire as well while I was working on it. That wire there, the red one, is actually the 110 volt input to the transformer, so we don't need that. But I don't want to cut it off just in case for any reason in the future. Say someone bought this from me and they're in America and they wanted me to get it to work in the US. I mean, obviously they'd have to provide their own 110 volt AC induction motor, but there's loads and loads of BSR decks in America because they were sold quite well over in America. So a motor wouldn't be a problem, but if I chop that wire off completely, they wouldn't be able to run this on 110 volts. So what we will do with that to make it safe is we will bend it over like that. We'll get some heat shrink, we'll put some heat shrink over it, and then we'll shrink that down, and we'll be naughty and just use my soldering iron because I can't be bothered getting the hot air station out just to shrink down this tiny little bit of heat shrink. So we will just give that a quick warm with the soldering iron. Just like that. So that makes that safe. We can tuck that out of the way now, and we don't have to worry about it. Like I said, if in the future this ever did want to be run on 110 volts, it would just be a case of swapping basically these wires over. Can tuck that out of the way under there. That's nice and safe. We will leave that wire disconnected for now. That's our 240 volt input, and we'll take our pay our attention to the neutral, which is this black wire there. So we'll just desolder that bit of fuse holder which is left on there. We'll heat that up and just get rid of that. Now, I'm not cutting the wires because they are rather short as it is, and obviously we do need to make them reconnect to where they're going. Now this neutral there that we've just disconnected, we can solder basically straight. I don't know if you can see this, it's rather difficult for me to show you what I'm doing and get it on camera. But basically what we're going to do is we're going to take this neutral here and we're going to solder it on that side there of the IEC. But first what we will do is we'll just cut a little piece of heat shrink. Don't need to be a large piece, just cut a little piece, and we'll slip that over the black wire like that and get that in there, and then we can solder that in place. There's my soldering iron. I need a longer wire on my soldering iron, I think. This is rather tricky. I could really do with buying some of that nice silicon cable and make it flexible, because it's a bit horrible this iron. Well, it's not a bad iron, it's a cheap nasty one from Maplin's, but it does everything I want it to. And it's a damn sight cheaper than keep buying tips for my Weller. In fact, my Weller needs a new element at the moment, and they're horrendously expensive. Okay, that's soldered on there. And we just put that bit of heat shrink over it, and we'll just shrink that heat shrink down, just like that. There we go. So as we can see there, just put the iron away. And basically that's what we've done there. As you can see, we've got it coming from the transformer. That's the neutral on the IEC, and like I said, we've got some heat shrink now over that, so that's a nice, good connection there. And next, what we need to do is we need to replace that horrible fuse holder that has been broken. And what we will do, we just see if we can. There they are. I knew I had some. We have some replacement fuse holders here. Now these are a little better than what was replaced, because as where that's a thermoset in plastic, this is a bit more forgiving. They don't break quite as easily, these. So we will install that. Oops, and we drop the screw inside. Come on, come out, screw. Get that in there. Put that on there. Tighten that up. There we go. So there we've got a nice new fuse holder in there. Then what we need to do is connect between that side of the IEC there and that tag on the fuse holder. So again, we'll get a couple little bits of heat shrink, because we do want to make sure this thing's safe, and best thing to do is anything that's going to carry mains voltage is you don't want anything exposed that doesn't have to be exposed. So heat shrink all the way. Let's find a bit of wire we can go between that contact and that contact, and if I can find something blue, I will keep all the mains voltage live connections in blue. So we've got a blue there. I think that would be good enough. Let's cut some of that out. Let's have a look at that there. There we go, we've got a piece of, it's not quite the same colour of blue, but it's close enough. And it's the same, it's basically the same thickness as what's coming out of the transformer. I mean, it wouldn't be a problem going thicker on the transformer. What you wouldn't want to do is go any thinner. That would be a bit silly, really. So we will always go with the closest we can. And we need to cut that about that long. There we go. So that there is what we're going to bridge between them two contacts. We will just tin up the ends of that to make it easier to solder. Where's my solder gone? There's some solder. Get the old iron out again. Oops. Get back here. Okay. Put you back over there. Just move this safe block because that's getting in the way of the soldering iron wire. I've finished with that for now anyway. And there we go. That's our piece of wire. We've got some bits of heat shrink, so we'll slip a piece of heat shrink. In fact, no, we don't need to slip a piece of heat shrink on just yet. We will solder it in position and then we will slip a piece of heat shrink on. In fact, what I will do is I will just tin up the connector. In fact, what I will do is I'll get rid of some of these wires that we don't need, because we're going to be redoing all this shortly. So let's get rid of that. Come on, out you come. So I could just cut that actually, because we're not going to reuse it, I don't think. Come on. There we go. Let's get that off there. So that's gone. Let's get rid of this old neutral here. In fact, I can just cut that. Oh, I'll desolder it from here. So I know we're changing how it was originally, but we are going to end up with an inherently much safer actual design, because obviously safety standards have changed a little bit since the 60s. This is never going to be up to code. None of this stuff. As soon as you work on this stuff, basically you've condemned it to never being technically safe to use, because you've changed it from how it was originally from the manufacturer, but you're actually making it safer. More of the idiocy of health and safety legislation. Don't get me started on that, because we'll be here all night. Anyway, we'll solder that in position. There we go. Got a decent connection there. We'll slip a little bit of heat shrink over that. Okay. Just like that. And we will shrink that down. Just like that. Put the other piece of heat shrink over it, and we can bring that round and we can solder it. In fact, we'll just snip that down because it's a little bit long. Take a bit off it. There we go. Get rid of that piece of dross. And we will solder that to the live side of the IEC connector, which is over here. I need a little bit more solder on that, I think. Where's my solder gone again? There it is. Just put a little bit more solder on my iron. Just tip that over. Now I've got it roughly in place, we can just perhaps flow a little bit more solder on that now. You have to need a nice hot iron for doing this, because obviously there's quite a bit of metal in an IEC connector, and if you don't use a nice hot iron you won't get a good joint. There we go, that's nicely soldered on there. Bring the heat shrink over it. Go on. What I might do is make that life a little bit easier to get that in there. I'll just slacken this off. I'll take that out again. And then we can perhaps pull that tight and then slide that bit of heat shrink over there again. What's happened is I've put the heat shrink in, it's bent over on itself and tried to go over on itself. I think the tag was probably still a little bit warm when I tried putting the heat shrink on it, and it's tried to shrink down before it's actually over. Yeah, I've buggered that up. I'll have to take that off and do it again. So what happens, I've tried to push this heat shrink over it while the connection was still hot, and it's actually shrunk down before it started to go over the connection. Which is me being a dozy bugger, so I need to cut a new piece of heat shrink and slide a new piece of heat shrink on first. I'll cut a new little piece of heat shrink and turn my heater down because I'm sweltering in here at the moment. I'll put a new piece of heat shrink on there. Over we go again. Let's connect this. Ah, you sod. There we go, that's gone on this time. And we'll let that cool for a second so we don't make the same mistake again and melt our heat shrink before we've actually got it in place. Let's feel that now. Yeah, if you can touch it then you're pretty sure that it's going to be cool enough. So let's slide the heat shrink over this time, and there, it's gone right on this time, no problem. Let's shrink that down. There we go. That's shrunk down nicely. And then we can reattach the fuse holder where we want it. Now what's happened to the little screw for the fuse holder? There it is. Let's stick that back in there. I'll stick that back in there. I'll stick the little screw back on the back. And there we go. As we can see, we have our nice new IEC, we have our neutral connected up, and we have our live coming from that side, and it's going to go through this fuse. The whole idea of that is that basically if this thing is left with the power connected to it and it's switched off, if anything happens and something shorts, it's still going to blow the mains fuse and kill power to it. So it's basically it's safer to have that as close to the mains input as you can before anything else. Basically we're going to utilise the switch in the deck, because it is rated for 240 volts, to actually switch on the amplifier and switch the motor on at the same time. So what we're going to do for now, we've got that wire there and we've got a connection there. We're going to connect them together, but we're going to connect them together with quite a nice long wire. So let me see what I've got in my magic box. Let's see if we've got anything suitable we can use for the wire for that. I really want blue. Should I just use that for now? Yes, I can actually. Another piece of that, I wonder. Another piece of blue. That's blue. That's too thin though. That's blue and that's too thin. That's blue and that's not too thin. That's nice and long actually, that'll do. Right, so we've got some more blue wire, and what we're going, in fact we'll use this, sod it, we'll use this piece here. What we're going to do is we're going to solder again this onto that side of the fuse there, and then what we're going to do, for now we're just going to solder it onto there and we'll put a little bit of heat shrink on that. That's just for safety. That will be being changed when we start reintegrating all this back into the record player and getting it to work with the motor and everything. But for now, just to prove this circuit, and we've got this circuit all finished, all happy and up and running, we're just going to basically loop that together. That will eventually go through a switch. So again, we just need to do a little bit of tinning here. So if we tin up the other side of the fuse there. There we go, and we tin this piece of wire. We will solder that correctly tinned. Let's put a bit more on there. Bend this so we can get it in a nice position. We will solder this on there. There we go, I'm happy with that connection. And again, we'll stick a little bit of heat shrink around that just to make it all look nice and neat and tidy and safe. We'll snip a little bit more of that off. I'll put that over there and down onto the fuse holder. Like that. And then we need to just shrink that down again. So where's the old iron? There we are. We'll just shrink that down. So I should really be using hot air to do this, but not everyone has a hot air station. You can use a lighter, or you can use a match, although that's a bit messy. I prefer just to use a soldering iron. Providing you're gentle, there's nothing wrong with using it. There we go. So that is our new fuse holder. Nicely in place, nice and secure. And then what we're going to do with this, like I said, we'll leave it long for now. We'll just take a little bit off the end there. Take another little bit of heat shrink. Something a little bit thinner. Yeah, that should be suitable. Cut a little piece of that. This is just for my own safety. While I'm playing with it, I don't want to be touching anything live by accident. We've got that wire there, we've got this wire here. We're just going to solder them two together and put a bit of heat shrink over it. And so that will be being broken again, and a wire running off to the switch, which will energise both the motor and there we go. That's a point actually, how I'm going to energise the motor when I've yeah, we're going to, I'm a bit of an idiot here. What I should have done is run that to one of these tag strips up here and then to the transformer. We'd have probably, yeah, we'd have to come off there again and go up to the tag strip, because we do need a wire for the motor, which I haven't thought about, which needs to come off there. And I'm an idiot, but I'll sort that at a later date. Let's get the power supply working, and then we'll have to obviously redo that to bring an extra wire, an extra neutral out for the return from the motor. Yeah, I'm a pillock. But we all make these little mistakes when we're working on stuff like this. Never mind. We'll slide that bit of heat shrink over there for now. Like I said, this is just temporary while I work on the player, so I don't electrocute myself off that connection. Let's cut that little divot off there, because that's stopping. And I cut through the wire. Come on, you little sod. Come on, you little sod. There we go. Get in. There we go. Slide that over there like that. So we will have to take that off again, but it's just for safety while we work on the unit. So there we go, we've got an IEC in and it's connected up through the transformer. Let's get that out. Right, now the next thing we will really want to do, oh, we need a fuse for there, don't we? What have we got in the way of a fuse that's suitable? We've got like 1 amp fuse to go in there, I think. Let's see what we've got. What have we got? What have we got? Where's my fuse there? Where is my box of fuses? How's that my box of fuses? No, that's all my interconnect leads. Well, I'm afraid you're just going to have to bear with me because I've misplaced my fuses, so I will pause this video again and I will be back shortly when I've found some fuses. Okay, we're back, and I'm sorry to say I've done my usual, cocked up again, and I forgot to press record before I started back on the job. I was too distracted by making myself a nice coffee. But we have my fuse kit here now. I'll just quickly recap what you've just missed while I was merrily chatting away to myself rather than chatting away to you. Basically what I did was I corrected my little error from before. As you can see, I desoldered that neutral again. I added an extra neutral, reheat shrinked it, and I brought that neutral over to this bit of tag strip over there. So that's where the neutral return from the motor is going to solder to when we get that far. As well as that, I have knocked that little thing up there. Now what that is there, that is a diode bridge, and that will replace that selenium rectifier there. And basically all that is 4 silicon diodes. I think they're rated at 1 amp 50 volts each, so they're going to be well under running this application. And if we put AC in them 2 there, we've got negative DC there and we've got positive DC there. And all we're going to do with that is basically we're going to leave the old selenium rectifier in here, but we're going to leave it disconnected, and we're just going to use that as a mounting point so that we can mount basically we can mount this to it, and it gives us a nice place to mount it. So what we will do is we'll just let's just cut these down a little bit because them legs are a little bit long. You can buy this as a standard package, as a little bridge package, but I'm sure I've got some somewhere. I've just had a quick look through all my boxes and I can't find any of them. There's absolutely nothing at all wrong with doing it this way either. Obviously I've done this that configuration many times in the past. What we will do is we will solder it like that there, so it's nice and secure, and then we will bend them sides round like that, and we will solder the 2 green wires that come off the transformer to those 2 there. And like I said, we've got positive at the top and we'll have negative down there at the bottom. So let's do that now. We'll get that, get the old iron, we're going to solder this in position here. So this selenium rectifier is literally just being used as a mounting point at this point. If I'd had some spare tag strip, I could have easily replaced that with a piece of tag strip and done all that on the tag strip, but I haven't. I don't know where my tag strip's gone either. I may have to reorder some, and it's bloody expensive for what it is, tag strip. I remember I bought a load at I think it was at a Radiophile or a BVWS event years ago. I got a big bag of it very cheap, but unfortunately I think I've pretty much used all that up now. And I was looking on eBay the other day for tag strip, and it was horrendous money for what it is. Come on, you come off there now. Come on, off you come. There we go, that's the first one off. Let's disconnect this one as well. And then that selenium rectifier is still in there for prosperity, so people can see Here's to come what a selenium rectifier looks like, but it is wired out of circuit and it won't stink up the entire house if it went off. It was still in circuit. There we go. Come out. There we go. So that's that disconnected from there. Let's get some more of our good old-fashioned heat shrink. Got something between them two sizes. Let's see what we've got in the heat shrink box. Oops. We go to the heat shrink box and we pick everything else off my other bench. Just stay up there. I don't want anything falling down. Okay. Ooh. Oh, that's nice. We have biscuits as well. Got biscuits to go with my coffee. Lovely. Sure, you're not meant to eat biscuits while you're working on electronics, but needs must. Ah, that'll do. That's a little bit bigger. That should do for our heat shrink. Oh, what's that one? Oh, that might even be better. Let's measure that one. No, that's the same as that one. Let's try this one here. So all we want to do, let's tidy these wires up. And we'll cut that heat shrink in half. Like that. I'll slip the heat shrink over. The heat shrink isn't 100% necessary because this is all on the low voltage side, but it does make things look a lot neater and tidier. And it does help to prevent any accidental short circuits in the future. So when you want to do a nice neat job on something, heat shrink really is the way to go. Okay, so we've got some bits of a nice heat shrink on there, and all we need to do is get a good contact on here and we can solder these in place. Just twist that round up. Oh, that snapped off. That was a little bit on the fragile side. We'll need to strip that back now. One of the problems you have with these transformers is this wire that comes out of it just actually comes directly out of the transformer. There's no tag strip or anything, so if you snap one of these off right at the transformer, you've got issues. Let's twist that back round there now. Make sure we get a good connection. That should be fine. We can solder that in place. Like that. We can slip our... Let's not make that mistake again. Let's make sure that's nice and cool before we put the heat shrink over it. Come on, go over. Just put the iron down while I do this. Come on. Oh, and that's snapped off again. That's not good. That wire is very, very, very fragile. Let's see what we can do here. Let's try scraping. Perhaps I didn't get all the varnish off when I tried scraping that before, so let's give it another scrape. Basically this wire, because it is transformer wire, has like a varnish on it, an insulating varnish, and before it'll solder, you have to scrape the varnish off it. Modern solid core like transformer wire, I think it's like self-fluxing, and the varnish tends to just peel off as soon as you touch it with a soldering iron. This old stuff doesn't, and you literally have to scrape the old varnish away before you can get the wire to solder. Let's try that now. Yeah, that's better. Let's just clean my iron off as well. Yeah, that's much better now. That's nicely tinned up. We can try soldering that back on there now. Yeah, as you guessed, that was my everything falling off my bench. I managed to catch everything with my knee. Ow. Just a second, just bear with me folks while I rearrange everything there. And fortunately I caught my soldering iron, because I did have my soldering iron in my hand when I did that. And I'm going to absolutely scream now as well. So I've got a really nice connection on there, as you can see. I don't know if you can see that. But I forgot to put the heat shrink on. So we will desolder. We're not having a good day of this today, are we? We will desolder that. We will put the heat shrink back on. Oh dear, I'm not very good at this video logging malarkey, am I? You see some people's videos and they are so professional, and then you see my efforts and it's like, oh bloody hell. It's absolutely ridiculous that one time I actually used to work in video production. Okay, I wasn't a cameraman, I did very little editing. I basically only ever used to do it when there was no one else available to do it, but I did actually used to work in that kind of industry at one point, and look at me now. Oh dear, my production values have definitely gone downhill somewhat. Anyway, sod it. We'll heat shrink that in like that. And that's the first one done. That's quite nice and neat now. And we will we'll give this one a quick scrape before we connect it, just to be absolutely sure we're going to get a good connection. We don't want that to happen again. There we go. Let's give that a quick tin up. There we are. Bend that round and we can solder that to that side of the bridge like that. Just make sure that's cool before we try and slip the heat shrink over it, because we don't want that shrinking before it gets in place. Push that over there like that. Let's shrink that down. There we are, that's nice. Make sure them wires are nice. And there we are. That is basically, that's our transformer. We're rewired to a new IEC, and we've bypassed that selenium stick rectifier with this nice diode bridge there. We have positive at the top there, we have negative there, which we can actually take off that side there because they're linked. That's the reason I put it at the back there. We need to I think what we're going to do, I'll test. Next thing we'll do is we will test that capacitor there and see if it's actually any use. Just have a quick slurp of my coffee. Let's take this out of its bracket again, like that. And now, where is it? Where's my test meter? Let's see. I'll get my ESR meter out, I think, and see what this says. Come on, out you come. It's got wrapped round everything in my drawer. Yeah, that'll do. And it's still got some charge in it. No, it doesn't go up to anything. Does it go? Yeah, it goes up to something this big at 16 volts. 40. We've got 4,700 UF. This is 5,000, so that's close enough. It wants us to short the probes. Okay, that's okay. Let's connect this up to the ESR meter and let's see what it tells us. ESR equals 0.04 ohms, and for a 4,700 UF capacitor at between, well, it has 10 volts and it has 16 volts, and it's saying 0.06 is good, 04 is even better. So actually there's nothing wrong with that capacitor. Even it's probably getting on for like 50 years old. Okay, apologies once again. Yes, my camera battery died yet again and I didn't see it, but as we can see, this is all back together now. We have the capacitor reinstated, we have a 1 amp surge limiting fuse, that sorry, a 1 amp slow blow fuse there, so basically it's got a little bit of surge protection on it, it won't blow straight away. We have the new IEC in, we have the diode bridge replacing the selenium rectifier. So that is pretty much the power supply rebuilt. We've still to do the earthing, but we'll do that when it's all back in the case, because we'll have some multiple earths to pull off there. So join me in the next instalment of this, when we will put this back in the record player cabinet, and we will turn our attention to rebuilding the amplifier and getting the amplifier as good as we can get it. And then we will tackle that deck, get that deck all nice and cleaned up, and then look at fitting a suitable replacement cartridge. So I hope you enjoyed that, and apologies for all the camera issues. I am waiting for a new battery for my camera to arrive. Unfortunately, like I said, it's on its way from China and it is taking a little bit of time. So I'm going to leave it there for now. I hope you enjoyed that little instalment. So thanks for watching, and goodbye.